Alright, so this video is on number 14 from the Unit 9 review. So let's see, there's a circle, there's this vertical line that's been graphed, and another line that's been graphed as well. And the first question, let's see, P is the center of the circle. And the first question is, what's the equation of the vertical line? So if you look at that vertical line, notice it goes through 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, etc. So every point on this line has all of the x coordinates the same. They're all x equals 4. So that's the equation of the line right here. By the way, if I graphed a horizontal line instead, that would like right through that diameter, or through that center point, that would have been y equals -1, because all the y values have that in common. Okay, coordinates of point B. Well, AB is a straight line. So if we made a slope triangle here from A to P, I could then duplicate it and end up going from P to B. So let's figure out what that is. So if I go across, the x's change. So -1 to 4 is 5 units across, and then 3 to -1 is 4 units down. And so that's the same as the 5 across and 4 units down right there. So then if I count across 5 from the center point, 5 across, 4 down, 5 across will get me to 9, and 4 down will put me at -5. And you can kind of eyeball it and see, oh yeah, that looks like 9, -5. So 9, -5. Okay, the next part says, find the equation of the tangent line at point A. So I'll draw the tangent line right here in blue. So it looks like this. And the equation of it, well, remember, we've got a radius drawn to a tangent line. And point slope form, remember, is y minus y1 equals m, x minus x1. Okay, well, the slope of this radius we already have. It's going downhill, so it's negative. The rise was 4 and the run was 5. So that means the slope of my line is going to be +5 over 4. And then x1, y1 is any point on your line. Well, we only know one point, A. So this is my x1 and y1. So when I plug in the point slope form, it's y minus 3 equals the slope, 5/4, x minus -1, which is x plus 1. Okay, so part D says find theta. All right, well, theta is right here. You might notice it's that angle right there. You could do it a couple ways. You might solve for this angle because that's in a right triangle, so we could use that, and then subtract from 90 to get theta. You might solve for this angle, which actually is theta, because you've got that Z shape, and these are both vertical lines, so they're parallel. So you could just work in this right triangle right here. I think what a lot of students in the past have noticed is that these are vertical angles. So this is also theta, and so then a lot of students like to use this triangle right here to figure out what theta is. So I'll draw that triangle by itself right here. This is 4 up, 5 over. Here's theta. By the way, you could have also just duplicated this triangle down here. This would be 4, this would be 5. So let's see, this is opposite. This is adjacent. So we'll use tan. So tan theta equals 5 over 4. So theta will be tan inverse of 5 over 4, which ends up being, let's see here, 51.340 degrees. Okay, so that's number 14. Number 15 has a separate video that I've already made, but I think it had a different number originally. I retitled it so that you know which one it is. Okay, hope that helps a little bit. I'll see you guys later.